right, so looking at page 157 and compound interest. So this is our formula, and it says to consider an initial principal P deposited in an account that pays interest at an annual rate R, expressed as a decimal, compounded in times per year. The amount A in the account after T years is given by this equation right here. So again, A right here, this A value, this is your end amount. The P, that's called the principal, but what does the principal also mean? Starting amount, yep, or initial amount. R, of course, is that interest rate. N is the number of times it gets compounded. See what it says right here? Compoundings per year. And then T is the number of years. Now, if it's only going to get compounded once per year, can you see how this formula would be a lot easier to use if it's just going to get compounded once per year? Because what's going to happen here is we're just going to have a 1, and we're just going to have a 1 here. So let's just say that we have something where we're going to have compounded annually is what that would be called. That means that it's only going to be, the interest is only going to be compounded once per year. And let's see, Tyson, give us an interest rate. 3%, okay. 3% interest rate. Okay, now I want you to think about how much money we're going to invest. Let's see, Lucy Jones, give me an amount we're going to invest. What's that? $25,000, sounds good. I like that. All right, and then let's say we're going to keep it in there for, so you guys are sophomores, so we're going to leave it in there for 2 years. We'll take it out, we'll say you're going to use it for college. Okay, so let's see how much money we're going to end up with then. So A is going to be our end amount that we're going to have. P is our principal, which is $25,000. It's 1 plus our interest rate is going to be 3%, so this is just 0.03. Because N is 1 because it's only getting compounded once per year. So I don't have to worry about dividing this by anything. And then it's raised to the 1 times the number of years, and we've got 2 years. All right, so this is what we're going to put into our calculator to find out how much money we're going to have. Let's put that in there and see what happens. So we're going to have 25,000 times 1.03 raised to the second. Can you see how this is an exponential growth model? See how this is our percent of increase? You guys see how that's the same as what we've been doing? It's really the same kind of thing. And so here we go. We're going to have $26,522. $26,522.50. Okay, not bad. Watch how I can quickly change this interest rate. Everybody do this. Go ahead and push second enter. And see how the last thing we put in there just pops up again? And let's change this interest rate. Let's make it 9% now. Now look how much more money we make. Okay, so by increasing that interest rate, we can make quite a bit more money. And now let's say we're going to leave it until you're out of college. Oops, wrong one. I got to do second enter. When I do second enter, I don't have to retype it all. And so let's say you're going to, that'll be 6 years from now. So then you'd have that much money at a 9% interest rate. But now let's go back to our 3%. Second enter. Edit it, go back to the 3%, and look at that difference right there, guys. The 9% interest rate for 6 years versus the 3% interest rate for 6 years. Huge difference, okay? And the thing is, too, like if you go to the bank and you look at CD rates, like the more money you're going to invest and the longer time you're going to keep it in there, the higher the interest rates they'll give you. So if you've ever heard that phrase, like it takes money to make money, like that's kind of why. Because if you're going to put in a lot of money, then you're going to be able to make more, you're going to get a higher interest rate, plus you're going to make, more money just because you have more in there to begin with. All right, let's flip over now. Let's do a problem where it's not compounded annually. So let's look at number 6, compounded quarterly. If we're compounding quarterly, what do you think the end value is going to be this time? 4. Yeah, 4 times a year. So now n is 4. So we're going to have to use that same formula, A equals P times 1 plus R over N raised to the NT. So it says use the given information to find the amount in the account compounded, earning compound interest after 5 years when the principal is $12.50. And for this one, we have an interest rate of 2.25%. So our principal again was $12.50. Our interest rate, we need to convert it into just a decimal. So what am I going to use then? Right, 0.0225 divided by 4, because 4 is the number of compounding, and then raised to the 4 times the number of years, which is 5. So typing this in is a little more challenging. It's 1250, parentheses 1 plus 0.0225 divided by 4. And then if I'm not going to put raised to the 20, because 4 times 5 is 20, I would have to use parentheses around this as well, if I'm just going to keep it at 4 times 5. If you're just going to put in 20, which is easier, then you wouldn't have to use those parentheses. And we get this, 1398.40. 1398.40 cents. Okay? Alright, so now, instead of doing number 7 the way it's written, we're going to do this for number 7. So for number 7, find the average rate of change of the amount in the account. Alright. Average rate of change is going to be basically just the slope, okay? So we're talking about at 0 years. At 0 years, how much money do we have in there? How much, guys? $12.50. Now we're doing this under the conditions in number 7. So we want to know at the end of our time, after 5 years, how much money are we going to have in there? So to figure that out, I'm going to have to come back over here and do this problem. So it's going to be A equals 1250 times 1 plus, here's my interest rate, 0.0125. If it's compounded daily, what am I going to divide by? 365. And then raised to, the number of compoundings is 365 times 5. So to type that in, I'm not going to edit that. It's kind of hard to do. I'm just going to type it in. 1250, 1 plus 0.0125. Just type it in there. See, if I don't put this in parentheses, it's going to raise it to the 365, and then it would multiply the whole answer for that times 5, and that's not what we want it to do. Oops, don't want that. And there we go, 1330.62. So now that I know my beginning amount and my end amount, the average rate of change means the rate of change per year. What's the average rate of change per year? Okay, so to find that then, I would just have to do 1330.62 minus 1250 divided by what? To find the average rate of change per year, what would I do? Divided by 5, right? that answer, divide it by 5. So each year we're making about $16.12. It's not too great, is it? Because that interest rate was so low. Yes. Put a 1 instead of a 5? You could have, but it's talking about the average rate of change over that whole entire period. So the rate of change in the first year may not be exactly the same as the average rate of change over all 5. Because the first year you're actually going to make a little bit less than you'll make in the other years because it's getting compounded. That's a good question, though. Yeah, so if it asks for the average rate of change over the entire time that it's in there, you would have to do the 5. Okay. All right, any other questions? Okay, so you guys have your assignment up there. It's on page 300 again. So, working with interest.